10:02 or so here, and I think we've got enough people to get started here. And so I'd like to welcome everyone, and hope you're having a nice day or nice evening here. My name is Gunnar Reisel. I'm executive director of CSSA. Our webinar series is made possible in part by you by helping us with donations for that series. You can do that by going to our website, cactusandsucculentsociety.org. We're always interested in your comments, so let us know your comments either in the chat room or maybe in the Q&A set. Well, maybe the chat room would be a good place to put that. In a couple of weeks, we have another speaker, and our speaker in 2 weeks will be Bob Webb, owner of Arid Lands in Tucson, and his topic will be Sansevierias. So we haven't done a Sansevieria one for a while, so that'll be good. So our panel today, let's see, let me close my screen here. If your screen is like mine here, we have Rod Haney. Good afternoon, I guess, Rod, for you.
Morning. It's still morning.
Still morning. What time do you have? You have 11?
11:05.
11:05. Not too bad. Okay. So, and then we have Erwin Lightstone from the Dallas area, and next to him we have James Lemos from Altadena, California, and then also from the same area as Rod, we have one of our board members, Jackson. And before we're talking about his research in nectaries, and I think we talked about that last time. So anyway, and of course our speaker today, Ernesto Sandoval. Ernesto, welcome. It's been a while.
Thank you.
I don't think I've seen you since Inner City Show, and then everybody was in a rush, and I would think we just passed each other on like ships in the night, so to speak here.
Right.
So anyway, I think we're about ready to start here. Let's see. It's my pleasure to introduce Ernesto. Ernesto has been seeking answers of why plants grow and how they look for nearly 40 years. Is that right? Can that be right? I don't believe so.
Hey, I started pushing lawnmowers at the age of 10, I think. So yeah. There you go.
Okay. He frequently lectures on a variety of garden clubs throughout the year, and particularly the succulent clubs of Southern California. He was a speaker at our 2017 CSA convention here, and desert plants have always been his particular passion here. He has been for many years the director and curator of the University of California Davis Botanical Conservatory. He shares his enthusiasm and knowledge with new students each year, and he explains and interprets the world of plants to a variety of ages, including the K through 12 level professionals and also master gardeners. He says he likes to promote plant liberation and encouraging gardeners to grow more plants in the ground when possible. Although he likes the technical language of botany, he prefers sometimes to relate things at a more natural level for all of us here. So anyway, let me please help me in welcoming Ernesto as he presents Feeding Succulents, How Fertilizer, Water pH, and Soil Can and Should Be Adjusted. Everybody give him a big hand, and then we'll go ahead and start here. All right.
Okay. Before we start, please put all questions in the question and answer category so it's easier for us to refer to them at the end of the lecture.
Yeah, so if you want to chat among yourselves, or if it's something that you want to relate to each other, then go ahead and use chat. But for the Q&A, we'll use that Q&A section for that. Okay, Ernesto, anytime you're ready.
Great, thank you. And I will say I'll try to anticipate some questions that have come up in the past in parts of this presentation. So I'll try to touch on those, but I definitely look forward to answering questions at the end as we go along. So yeah, I did this talk to the San Luis Obispo Club a few weeks ago, and I've modified it a bit since then, made some improvements to it, like I always try to do. And so I'm talking about acidification, fertilization, and soil. And I'm going to go a little bit backwards in what I discussed there and sort of finish off with the acidification part and try to spend a good amount of time doing that. you know, just really quickly, you know, succulents are just a normal plant, just like any other plant, that do these different things of you know, photosynthesis, and you know, using the roots breathe in oxygen because they can't do photosynthesis, and the plants you know, soak in carbon dioxide. Roots actually let off carbon dioxide, but they're just really water efficient, and so they have modifications for that. Okay, so anyways, today I'm sort of focusing on really the needs of roots and how they what they need and how they work. Okay, so yeah, roots only do respiration, so they need oxygen. All right, because they're taking sugars from the top of the plant and they're using that energy from the sugars to do their work of grabbing water and minerals and nutrients out of the soil. And for roots to be able to do that really well, they need to have abundant amounts of oxygen to do their job. Most plants do much better with more oxygen than less oxygen, because again, they do respiration just like us. Okay. So I just want to really quickly go through this. What are some of the needs of roots? Well, they really typically need temperatures below about 70 degrees. Okay, roots in general do not like very warm temperatures. Even just a few inches under the soil in deserts, it actually starts cooling off quite rapidly. So maybe roots near the surface are getting really hot, but a great majority of roots are down a few inches below, and they're actually relatively cool for most of the year. They don't like it hot. This is kind of something that I was talking to someone recently, and cam plants, those plants that do cam photosynthesis, where they only open up their stomata at night. Someone was telling me how their roots need to be below 70 degrees, drop down in temperature to open up their stomata at night. And I dare say that actually is the whole plant, and that's why plants from warm places. Plants that are from temperate places where it cools down at night, and if they're grown in greenhouses, they may not grow as fast because they stay warm into the night and they don't open up their stomata for cam photosynthesis. So that's a little aside there. Okay. Again, roots need oxygen. Okay, it's really, really important. I can't emphasize that enough, and I'm going to talk about multiple ways to get it to them. Of course, they need water, especially in containers. Things can dry out quite severely, more so than in most drought years in the ground in the desert. So they need some amount of moisture, and I'll talk about more of that. And then, you know, something I'm going to spend a decent amount of time on talking about is nutrients. You know, roots need to grab those nutrients for themselves and for the rest of the plant, and nitrogen, phosphorus, and potassium being the big ones. Okay. And then this is what I want to, you know, I'm going to sort of be emphasizing this part right here, is the part of pH. And that's it's a big paragraph there, but basically, you know, succulents, a lot of succulents live in desert soils that are mineral rich. They tolerate alkaline conditions, but they actually do much better at grabbing nutrients under acidic conditions. And I'll talk about why that is with respects to electrochemical gradients and things like that. Anyways, I'll try to simplify it and explain that. Okay. And then, you know, I'm going to talk more in detail about acidification later, but I want to touch on this. How to acidify in small scale. People will use 1 teaspoon to 2 tablespoons of vinegar, of white vinegar, per gallon of water for acidification. And you really want to be measuring pH and you know, adjusting, using something to measure the pH with, whereas pH strips or a pH meter, to really dial it in to get to about 5.5 to 6.5 in there. Okay. And I'll talk about that more in a little bit. All right. So, you know, Gunnar talked about my thing about promoting plant liberation. And many years ago, I saw this chart here that compared plants in the ground, in the container on the left, the blue, versus plants in the ground on the right. And this chart was made for leafy plants, but I'll talk about it with respect to succulents. Okay. Water. Plants go from the soil goes from near saturation to your plants wilting or water stressed in 1 to 3 days. Okay. Whereas in the ground, they call it field capacity, and then the plants wilt in 1 to 3 weeks. Okay. And again, that's leafy plants, but succulents, again, will be stressed out for water after a few days, all right? But in general, we underwater them so that they don't have rot issues because of their sensitivities to too much water with respects to a lack of oxygen, okay? So aeration low to high in a container in one day, whereas it's typically adequate in the ground unless you're in like heavy clay soil, in which case you're gonna amend the soil to increase the capacity to grow succulents in it, or you're gonna limit yourself which kind of succulents you grow in your soil because of the lack of aeration, okay? Nutrients go to high to low in a week or less in a container. Why is that? Because when you add water, you flush out nutrients and you dilute them out, and it's a limited volume of soil. So you have to give your plants and containers nutrients if you want them to grow. If you want them to go into suspended animation, well, maybe you don't fertilize very much. Kind of like what people that do bonsai do, you know, we're kind of bonsaiing our succulents in containers. Whereas in the ground, because roots have a much more extensive reach, they spread out much more, it takes a whole season to really use up all the nutrients in the soil that the plant needs. Okay, so plants in the ground have a much more extensive root system, so they can grab more nutrients, and life is much better that way with respects to nutrition in the ground versus the container. pH can change 1 to 2 units in a few weeks or a month, whereas it's fairly constant in the ground. And a pH of unit change of 1 is actually 100 times different, or 10 times different, excuse me. 2 units is 100 times different. So that's quite a drastic change. And I'll talk about more in detail a little bit later about that. Salinity, you know, you get salt buildup in a container, okay, in weeks to a month. And that's why it is important to flush your plants through every once in a while, ideally with good water, or and we'll talk about how acidity helps that a little bit. It builds up over a season in the ground. This is a really big one. Temperature is a really, really big one, where you can have a 40 to 50 degree change in a container because of sun beating on the side of a container, versus it's fairly constant in the ground. And I talked about how temperature is really important below 70 degrees for roots. And so especially your plants that are on the west sides or where sun's beating on them, it's really important to keep the sun off those pots so that the roots don't get overheated and can't function, okay? And disease susceptibility in a container is basically is greater than in a plant in the ground. That's why we often see pests pop up in our container plants versus a lot less plants in the ground, because they're actually more stressed out. If you look at everything on the left side in the container there versus on the right side, almost everything on the left is more challenging to a plant in a container versus being in the ground. You know, again, if the ground is well amended for succulents in particular. Okay, so just those things are to think about. And, you know, I always tell people, you know, this is why you should liberate your plants, because growing plants in containers, you're kind of torturing them. Okay, sometimes you're managing the torture, sometimes you're not. All right. So this is what this was our soil mix at UC Davis, the UC Davis Botanical Conservatory. We called it our succulent mix. And what you'll notice, it's 66% organic. And actually, we've modified the recipe recently, so I'm going to talk about that as I go. So 3 parts, 5/16 red, what people call red lava, or scoria, okay, or 1/4 inch pumice when we had it available in the past, and now we have it available again. Okay, and then some coarse sand. Questions about why we use that. Some peat moss or coconut peat to it's organic matter that doesn't break down, and organic matter is great because it grabs some nutrients. So a little bit in there is good. And then we had a little bit of redwood compost because we used the soil mix for other things as well. Okay, and then for pH adjustment, we'd add some 3 pounds each of oyster lime. Dolomite was a really big one because that's a good pH stabilizer. And then I mentioned how the sand, we use it for top dressing, and I'll mention that more in a little bit here, okay? And what I want to point out is that, especially for our succulents, commercial mixes have way too high of organic matter, and as that organic matter breaks down, especially in warm situations where we grow most of our succulents under warm conditions, that organic matter breaks down and those coarse particles become finer and finer and finer, and they go closer and closer together. And that means more water in the media and less oxygen, which we know is bad for succulents, okay? So porosity decreases. So this is why you wanna cut the use of organic matter or increase the use of inorganic materials in your mixes for your succulents, okay? And then the mix is great. I mean, C&J Cactus in Southern California and a lot of nurseries use organic rich media with maybe a little bit of perlite, sometimes some pumice, very light, easy to grow for small young plants, but long-term, our plants will suffer with lots of organic matter, okay? So these are some of the components of our mix there at UC Davis. And I want to mention the number 12 mesh sand because I love using this as a mulch when I plant seeds, okay? And this is what we had in our soil mix. It's a sandblasting sand, number 12, it's coarse sand. And then there are the components again. I mentioned these before, okay? So this is our newest mix that we came up with. We really were not happy with the red lava, the scoria in the mix, because there's been some a lot of growers have mentioned how scoria may not be so good and compared to pumice, and we were kind of having some like not so. We weren't very happy with the growth of our plants recently in the last few years when we had the red lava. We were using it for about the last 3 or 4 years, and so we finally found a source of some pumice. And so this is our newest mix: 5.5 yards of 1/4 inch pumice, a yard of a little bit of red lava in there because it actually has some minerals that aren't in pumice. Okay, and then instead of sand, we're using decomposed granite, a very small amount, 1/16. So because decomposed granite can sometimes have a lot of fines in it, and so we wanted to make sure we didn't have too much of it, because too much of it starts plugging up the mix with all the fines that you can find in some batches of decomposed granite. And then 1 yard of coconut peat, okay? And basically it's 1/8 of the mix is organic matter. And then some dolomite for pH stabilization, as I mentioned before, okay? And so what you'll see is the mix is 7/8 or 87.5% approximately inorganic. So all that material is very slow to break down. When the organic matter does break down, and it's peat, or coconut peat, which takes a long time to break down, it means the mix, the combination of porosity and water holding is going to be very stable for quite a while in the mix. It turns out pumice does eventually break down and become finer, probably because of acidification by the plants and people adding. And so the mix does eventually, but not nearly as quickly as with lots of organic matter in there, okay? So one of the things that over the years that I've done, sort of talking to people and doing a little bit of research, et cetera, is what I found is that pumice holds about 15 to 20% more moisture than red lava, aka scoria, okay? And that's because pumice is made with water coming into contact with lava, and exploding out of a volcano and kind of being like popcorn, okay? And it's actually got a lot of micropores and then coarse pores, megapores, whereas red lava only has like pockets of air in there, and it's somewhat porous, but not nearly as much, and it's more dense. So it doesn't hold as much pockets of oxygen as and as much water as does pumice. So pumice really makes a better amendment, okay? And then one of the other things is in doing some research and finding out why is the red lava, the scoria, worse for succulents? And it turns out that it's higher in certain elements, and especially when the pH goes down on the low end, down about 5, you have too much aluminum and manganese. Possibly fluoride. I sort of haven't confirmed the fluoride part. I saw it written somewhere, and it wasn't the research article like the one that mentioned aluminum and manganese, and you get some toxicity effects from those things. So, and again, multiple growers over the years have noticed a slower growth when they use higher amounts of scoria, and we've had that observation as well. I guess observations. I don't know that it's been like researched comparison really well. Something it'd be tempting to do. Succulents grow really slowly, so it's hard to like really get good data in just a year or two. But anyways, there's a lot of experience that shows that. Okay, so here's our current mix. I have a Wowitchia growing in it there, and what you see is a very small amount of the scoria, the red lava, lots of pumice, and a little bit of organic matter. You can't really see the decomposed granite in there. Okay, but again, really high porosity. And a lot of our desert plants love the high amounts of the coarse pores with a little bit of water holding to keep the plants happy. So the more oxygen the roots get, the more water they can handle. And Wowitchias love water combined with lots of oxygen. Okay. All right. Again, mention the commercial mixes. They're much too organic rich that breaks down, etc. Okay. So at home, it's hard to get these components in different places, and here in the US, pumice is becoming more available. It sort of comes in waves, availability, but one of the ways you can get it is in feed stores. And what you do is you take, you add about 1/4 to 1/2 of what's called dry stall, which you can get it at feed stores, add it to whatever cactus mix you buy, and you will have a much better, more stable media than what they sell at the store with lots of organic matter. Okay, even the best cactus mix that they sell at most nurseries has way too much organic matter because no one's going to pay 3 times for a bag of really good succulent mix versus organic rich mix. I think it's kind of like a PC versus Mac, but anyways, I digress. Okay, so don't use what's called stall dry. That's actually an absorbent that isn't good for the plants because anyways, it's not good for the plants. You want to use what's the pumice dry stall. Okay, and there's other places to get pumice also. This is where I recently started getting bagged pumice from. Is General Pumice Products in Apple Valley down in Southern California, and it's convenient for me to get it in bags. So I get a pallet of 50, 25 pound bags, and it's sifted, so it's really good sized, like the 1/8 inch and then 3/16, and the 1/8 inch is really great for propagation. So we've been using that a lot more, and it's really nice to have a source. We get our mix made by American Soil Products in Richmond, California. And they use this pumice. They have pumice available. Okay, so I want to show you the beauty, just really quickly, of very low organic mix for succulents. In this case, in a succulent tray, sort of a miniature planting bed. Here's a bunch of African succulents that I planted in June of 2008 in this planter that's about 24 inches deep, 4 foot wide, and about 12 to 14 inches tall. It's actually sloped. Okay, there they are right there. All right, so it's like something like 1.5 meters wide, a little under 1 meter deep, and maybe 1/3 of a meter tall. Okay, so and then there they are in 2016. So if I go back, and 3 years later, look at how much the succulents grew in pure pumice, and we were fertilizing. Okay, not every watering, like every 3rd watering, we were fertilizing because we didn't want to over fertilize succulents. And there they are in 2016, several years later, and then this picture was taken just a couple months ago, and pure pumice. All right, it's like plants growing in the ground because the roots have much more availability to spread, and so even though they're in pure pumice, we fertilize, they get all the nutrients they need, they have more room to grab those nutrients, the pumice holds on to a little bit of nutrients, and it makes for very fast growing plants. Okay, so just to finish off talking about containers really quick is containers come in all shapes and sizes. Okay. Okay, this is for the I don't know what it is, immobile gardeners. So what makes a container? Almost anything. This is for the mobile gardener, a wheelbarrow. This is for the tired or retired gardener. Sorry that I tread with bad jokes here. this is for the potty mouth gardener, okay? And you know, which of these is the crappiest of all containers? Yes, it's the toilet there that has no drain hole, okay? So at the very least, a container should have a drain hole, especially for succulents. And it's really scary to see out there on the internet with Instagram and Facebook, all these people growing succulents in containers without holes in the bottom, okay? And there are things that could be done to deal with that, but in general, you want to have drainage to get excess water out of there, okay? So what makes a good container? Well, ideally containers should look like this, okay? Taller than it is wide, narrows at the base to decrease what's called a saturated zone, especially when you have the finer mixes that are heavily in organic matter, okay? And I'll talk about that saturated zone really quick in a bit. And it's filled with a suitable mix for your plants. And in general, all plants love oxygen. And so we use our succulent mix. We actually use it for 90% of our plants because all plants grow better with lots more oxygen to their roots, okay? Have I emphasized oxygen enough? I don't think so. Oxygen is really good for your roots, okay? So Gene Joseph's at Plants of the Southwest and his wife there, here's a display of some of their succulents, okay? And look, oh my gosh, they're growing in containers that aren't right, like I was talking about ideal container. But the containers are filled with the right mix and they water accordingly. And you know, succulents don't wilt, right? So how do you know when it's time to water them? Well, you know, with the pharaoh cactus here, you can probably stick your finger in the soil and feel the moisture. And you know, this is an amazing moisture meter compared to anything you can buy at the store, okay? But what they did is they had a little poppy, a little Western native poppy, Schultzia, that they allowed to grow as sort of a little bit of a weed in their containers, not a weed because they want it there. And they would wait for this to wilt. And when it was wilting, they knew that the soil moisture was really low and it was time to add moisture, okay? And Gene there explained to me many years ago that he was having trouble with pachypodiums dying on him in the middle of winter when he wasn't watering them. And he said, what the heck? I'm gonna give them a little bit of water and see if that helps them live. And he started in the winter time when they were leafless, Pachypodium brevicali and a few others that really go dormant. He sprinkled a little bit of water on them in the middle of winter time, just to moisten the soil a tiny bit. And he said he started having a lot less die off in the middle of winter. And it got me thinking, roots like moisture. So what happened? When it was bone dry, those roots would get really, really dry and start dying from a lack of water. And then a rot would move in and kill off the plant. And we all know how quick succulents die from lack of moisture, from rotting, excuse me. And sometimes it's induced from lack of moisture just as much as it's induced from too much moisture. Okay, so that's how you make sure that the plants get a little bit of moisture, the right amount of moisture, is by having some kind of moisture meter. And I use a few of my more leafy succulents or leafy desert plants in our growing areas as my my indicator plants, telling me it's time to water. Okay. I have a Pereskia that I use for that. All right, so there's this thing called the saturated zone at the bottom of a pot, and the finer the mix you use, the more water it holds, and the thicker this layer at the bottom of the pot called the saturated zone is there. And it's a function of gravity pulling the water through the media, but then the media being like a sponge and holding on to the water. And the finer it is, just like a sponge, it holds a lot more water than if you were to take one of those like Brillo pads and you know, try to soak up some water with it. It won't, because it will hold a little bit, but not nearly like a sponge. So the coarser the mix, the less of this wet, water-rich, oxygen-lacking zone that you have in a container. Okay, and again, as your mix breaks down, it's a lot of organic matter. You go from the left when you just bought it to the right, as you know, over time. Okay. So people always say, oh, I will add stuff in the bottom of my container to increase drainage. Well, when you put junk in the bottom of a pot, especially all the way across the bottom, you're not increasing drainage. You're taking that saturated zone and you're elevating it up. It's just like, you know, when you have a pot, if it goes up or down in your hand, or, you know, up on a ledge or down on the ground, it still has the same amount of moisture holding. And anyways, stuff all the way across the bottom there does not increase drainage. If you were to have it be like sloped or mounded, then water will draw to the edges where that media is and drain out. Okay, so this is why pots that narrow are really good, because they have less of this volume at the bottom that makes that saturated zone. Okay, so sometimes what I'll do is when I want to decrease that in a large container, is I'll take some kind of inverted pot that's nice and sturdy and flip it upside down, or put a mound of stuff like over the drain hole, but not all the way across. Okay, and you're basically taking away the volume at the bottom that's a combination of porosity and gravity. Okay, so we can talk about that more later. Okay, taller pots are great because they are drier near the top. Okay, but you still have the same type of saturated zone if you have the same media across them. But a taller pot will be drier up near the top because gravity pulling water through than a shorter container. Okay, all right, so let's move on here. Okay, so really quickly before I get to the nutrient part, I want to talk about when to transplant your potted plants, because many years ago I did one of these lectures in fall, and then everybody was going away here in California and like, I'm gonna go transplant all my potted plants, my succulents, and I was like, I didn't explain a really important part, which is timing. So generally, when you transplant when things are beginning or in active growth during their growth season, not as they're going dormant. The worst thing you could do is as they're going dormant. You want it when they're active or they're starting to be active, so that they recover from that. Okay, so container plants, you typically do it in the warm months, spring through midsummer. Succulents, you wait a little bit longer when they're outside because it's a little cooler around the pots and the air, so you wait a little bit longer, late spring to early summer. I didn't give you months here because we all live in different climates where spring is a little bit earlier or later. Okay, in-ground leafy plants, spring through summer. So you typically, here's my general rule when I transplant my succulents, is I wait till I stop transplanting about a month before the weather cools off. Okay, in Southern California, you could probably do it all the way around most of the year, but in Northern California, we really have to stop by about late September, early October, stop transplanting our succulents outdoors because they will not have enough chance to recover. Okay, so okay, really quick note about transplanting is here's a cactus in a container here. There's your saturated zone. There's no roots down there. You take it and you replant it into a bigger container. And what you want to do is maximum 1 inch on the edges when your roots are dangling inside of the new container. All right. So succulents and low water use plants really should be no more than an inch gap, unless you're using really exceptionally well drained mix like pure pumice or something really coarse. You could grow your succulents in pure gravel if it wasn't minerally too rich or something like that. Okay, because I know pumice isn't available all around the world. Okay, so what I want to show here is why you don't do this, why you don't put a succulent in a really big pot. Too much soil for the plant to remove the water before the soil, anyways, too much water before soil starts breaking down because of fungal and bacterial activity. So when you plant your small plant into a giant pot, and I see pictures of this on the internet all the time, people doing this, roots are going to rot, and you're going to have a party. The bacteria and the fungi are going to have a party at your expense. Okay, so don't do the over transplanting in too big of a pot. Okay, all right. And I mentioned temperature before, and especially for those people that grow succulents on windowsills or outdoors, you want to be really careful to not have the sun beat on the sides of your container, because I mentioned the importance of temperature. And after about 30 minutes or so of sun beating on the side of a container, you can get temperatures up to 140 degrees Fahrenheit. So what is that, like 50 degrees Celsius or something, beating on the side of the container, and that's going to really cook roots, and roots are going to die. They're not just going to suffer, they're going to die. And it turns out like clay pots insulate much better than plastic pots because they have air trapped in them that keeps heat from moving through. All right. And then it turns out that high fired clay pots, like the ceramic pots that are really popular with succulent growers for display purposes, those actually are so dense, they actually don't have any air pockets because the air pockets have been all sort of heated out of there, and the clay has melted and fused together, and so it's really solid. So it actually lets a lot of heat through. So you want to be careful not to let sun beat on the sides of those containers. On a windowsill, especially where there's little air circulation in a warm climate, you can have a lot of sun beating up your containers, even on a windowsill. Okay. So, you know, a lot of people grow containers on windowsills, and so they want to grow them in a tray of some sort. And you really only want to use trays under plants to prevent damage to counters, tabletops, etc. Otherwise, when you're growing outside, you really shouldn't be using trays underneath plants. But when you have to, what the really important thing is to elevate the plants in the tray with gravel or something to elevate it so that when the water drains out of that container, drains into the tray, it doesn't have a connection where it gets soaked back into the container, because in this tray, water lands in there, water evaporates out of there, but the salts stay behind. And unless you have really good water, you get salt buildup over time. Okay. What I do at home is I use dilute water soluble nutrients, and I have our reverse osmosis water that I water my plants in, but I always have them where they drain out into a tray. And you know, when I can, I elevate them. Okay. All right, let's get to pH and acidification. This is what we're all here for today. All right. So this chart right here is this really beautiful chart that I saw many years ago in a container soils class that I took, and it shows the availability of nutrients based on pH. And if you see that there's a sweet spot somewhere in here between like 6.0 and 7.0 where most nutrients are available, okay, and they drop off in either direction. And typically we have issues with alkalinity because a lot of municipalities will acidify the water in the pipe. Sorry, they add alkalinizers to the water in the pipes so that the pipes are not acid, because acidity is harsh and will break things down. And especially when there's lead pipes or pipes that have things that people don't want to consume, that's an issue. So a lot of municipalities add something that makes the pH somewhere around 8. And it's great so that your body doesn't get toxic chemicals, but it's not good for your plants. Okay, so we're going to talk about how we acidify, right? But anyways, it's really important to have a pH around 6.5, okay? And we'll talk about why that is. And here we go. This is why. So nutrients, nitrogen, here we go. Soil and organic matter are negatively charged, okay? It's literally a very negative world out there, okay? All right? So it's very negative out there around, all right? And you know, I'm sort of relating this to chemistry a bit here, okay? All right. So yeah, soil and organic matter are negatively charged, and a lot of nutrients are positively charged, okay? So like nitrogen, you can get it in ammonia, NH4 plus, or nitrate. And it turns out nitrates, because they're negative and soil particles are negative, nitrates just flush right on through. And when you have a big amount of cows in one area, all those nitrates, you know, go through the soil, get into the water, and cause problems in wet areas and into estuaries and, you know, down the Mississippi Delta, all this stuff. Okay. Anyways, so it's actually better to use ammonia for fertilizing, because ammonia actually locks into the soil and then the plants can grab it, whereas nitrates just flush right through. Same thing with phosphorus. Okay. So this is why we have to add phosphorus for plants, because it actually washes right on through. Potassium positively charged, so it actually you know, the opposites attract those. They sort of lock into those negatively charged particles. And the finer the media, like clay, organic matter, has much more charged sites than coarser materials like sand that doesn't have any charged sites, or like something like pumice. Okay, sulfur negatively charged. That also, I guess, that also washes through. Nutrients, calcium, magnesium, the rest of them are all positively charged. Okay, so manganese, yeah. So what plants do to grab the nutrients out of the soil is they actually make acids, and we call them protons. They're acids, and these acids then are made in the roots, and they're made in the little root hairs. Okay, and this is why when you have plants that are kept too dry, they don't make many root hairs, and they actually don't grab as much nutrients as plants that are watered regularly enough so that they make root hairs. Okay, so they take those H plus, those protons, and they put them out into the surrounding environment, the soil, typically the soil. And what that does is that actually loosens up all these positively charged nutrients, because now you're acidifying, now you're making it more positive, okay? And that's called acidification, okay? And so those are all out there, and that loosens up these other things here, these positively charged minerals and nutrients, and then the plant absorbs those. So they actually do an exchange, all right? They put those out there, and then they pull in the nutrients, all right? And if it's really alkaline, that means it's in the soil, there's a lot more OH minus, it's actually much more negative, and it's actually a lot more work for the plants to grab those nutrients. And it's actually, it's what they call it, electrochemical gradient. And it's a lot easier when there isn't, when it's more positive out, sorry, when it's more positive out there, so the nutrients move more easily into the plant needs less work. And so with municipalities adding alkalinizers to the water, all of a sudden it's very difficult for the plants to grab those nutrients, and that's why it's really important to acidify to help aid the plants in grabbing the nutrients. The plants will do it on their own, but you're gonna make their ability to do it more easily if you help them out by acidifying. Okay. I know there's going to be a lot of questions about this, so we'll talk about this more as we go. Okay, so you know, the general consensus out there is that you want acidity of about 5.5 to 6.5 to make the roots happy, to be able to grab the nutrients. And probably a little bit on the low side is good, because the nutrients and the soils, they're a little bit on the sort of on the negative side. And so by dropping it down a little bit on the low side, when it hits the soil, you get the right pH and for nutrient absorption. Okay, so you know, low mineral water like what we have in Woodland, Davis in the wintertime, or you know, in the San Francisco Bay Area, where they get water from this reservoir called Hetch Hetchy that snow melts, really low mineral rich water, to acidify, because of the city adding alkalinizer. It takes about 1 teaspoon per gallon of water, okay? But again, I'm just giving you generalities here, but it's really important to get some kind of pH strips or a cheap pH meter to measure it and adjust it to the right amount. High mineral rich water, like people with shallow wells in the San Diego area, or they're getting water from the Colorado River, and only half the water makes it there. The other half evaporates on the way there. It's very sad. It takes about 2 tablespoons per gallon of water. Okay, I'm sorry for those of you that do metric system. I know it's a lot better, but this is what we have out here. Okay, I like citric acid as a safe alternative when I'm doing it in large batches, because it's a very safe acid. You know, citric acid that we use in lemon juice, etc. Okay, so again, it's best to test the pH of the water and adjust accordingly to get it to the 5.5 to 6.5 level. Okay. So my friend Barry Rice, who lives here in Northern California near me and has been growing a lot of succulents, has been doing some amazing astrophytum hybridization. He got into the Echinopsis. He has a really good collection of Echinopsis. They don't take much to grow, but he was having rot with a lot of his plants, and he suspected it had to do with their inability to grab nutrients and the wrong pH, and that probably promoting fungi and bacteria over the happiness of his plants. Okay, so he got this famous paper that was written by Elton Roberts and Malcolm Burley a number of years ago, and he actually has it posted to his website. And multiple people have this paper, on their websites that you can find. So if you look for it, you'll find it. Okay. And he said, if I have seen further than others, it's by standing upon the shoulders of giants. Barry, what you're saying is that by finding out information that others have and that others have done research on, it's going to help me be better at what I do. So it's really important to learn from others and their experiences. Okay. Yeah. So yeah, let's move on here. You know, Barry uses a completely inorganic media that it's 4:3 ratio of pumice and crushed granite, and he fertilizes with a complete fertilizer. He basically took the information that Malcolm and Burley, Malcolm Burley and Elton Roberts published, and sort of follows them, you know, based on what they wrote. Okay, you know, I go back for a second here. You know, he gets to that, he dilutes the nutrients to about 50 parts per million. They're succulents, they don't need a lot. So when people in nurseries, when they're really pumping plants, they get like 200 to 400 parts per million to grow plants really fast. Okay, but you don't need to grow them super fast at home. Down to about a quarter strength is what he's getting to. Okay, so there's this whole nitrogen debate that you know, Roberts and Burley had, talking about you know, the importance of certain nutrients because of plants getting them, etc. I would say that some of their science, their practical horticulture from that paper is really good. Some of the explanations that some scientists don't quite agree with. Okay, but whatever. You know, he's getting the ratios right and pH, etc., and plants grow much better. And there's his recipes down there on the right. Okay, I won't bore you with those. But here's some of what his components that he uses to do this. There's this pH meter that he got. Okay, water changes seasonally in a lot of municipalities, especially when people use surface water versus well water, and so he has to adjust it throughout the year to make sure he has the right pH. Okay, and so look, he used to need 275 to 315 milliliters of 5% vinegar per 30 liters of water, and now because we get a lot more surface water from the Sacramento River, he's down to a lot less vinegar. Okay, so it's really important to measure it, especially if it changes over the season. Okay, some places have much more stable water sources. And there's this plants assortment of plants. He's doing a lot of Ariocarpus, and he's gotten into a lot of different cacti. He's made some amazing hybrids of Astrophytum and growing a lot of Ariocarpus again. And he said rot is a thing of the past for him. He's having a lot less rot problems because, one, he's giving the plants nutrients, and then he's giving them the right pH so they can grab those nutrients. That equals healthier plants. Healthier plants equals less disease susceptibility. Okay, so you know, again, I can't emphasize enough to giving the plants a little pH a little bit on the acid side. And I'll just mention a couple other ways that people do this. All right. So at the Huntington, they have a portable nutrient injector that they use. So this is actually probably a combination of nutrients and pH adjustment here. So they have their water source on the right side there. So it's a Dosatron nutrient injector. This is like the standard, like the best type of injector there is out there. You can buy knockoffs on the internet, but this is the most reliable, highest quality one that a lot of nurseries will use. Okay, and the flow is to the right. So what happens? This thing is really sensitive to particulate matter getting in there. So it's really important to have a filter, a micron filter that keeps anything that's gonna scratch up the inside and ruin the seals on that. Because this thing is like this pump, and it's like siphoning water, siphoning stuff, whatever it is, out of that bucket down there, that container, and sucking it in. And it's really cool mechanical, kind of like a pump that's being run with the water, the pressure moving through there. And again, the filter is really important. Okay. The same thing going on here. One of the students that works for me, Gianluca, he actually helped us come up with our newest soil mix that we have, because that's kind of what he uses. You know, he measured his pH, and in Davis, is starting at 8.5. Okay, and he has a lot of succulents, so he's brought down his pH to 5.5 with a 2% dilution into 2,000 gallons of water, or actually, sorry, he can make up to about 2,000 gallons of water with this this dilution here that he's using, and he's actually using phosphoric acid. Okay, he's also adding nutrients in there, so that's the nitrogen sulfate. But the important thing is he's using 600 milliliters of 85% phosphoric acid in this 55-gallon drum, and it ends up being 2% dilution, and he can get about 2,000 gallons out of this. Okay, and you know, phosphoric acid is a stronger acid than vinegar. It's if you don't know what you're doing, I really recommend using citric acid or vinegar, because they're very weak acids that aren't going to cause problems for you. Okay, so you know, he knows what he's doing. He's a scientist. He's a mathematician. You know, he was saying that with one watering, he started seeing immediate results of growth in his pseudolithus and white sloana, plants that had not grown for him at all, because he adjusted the pH, and also because he was adding nutrients. But I believe he was adding nutrients before, but when he adjusted the pH, that's when things like, you know, his plants are growing much better than they were before. And we've all noticed this sort of thing. Okay, so thank you very much. I'll open up the floor to questions now, and I hope that this was helpful to all you guys in a variety of ways.
Okay, I see in the Q&A section there are at least 34 questions right now here. So that's
Okay.
By the way, Ernesto, thank you so much for your presentation here. It's useful information for all of us here. We're always interested in tips and techniques and ways of making our plants grow faster here. Let's go through some of these questions here, and Ernesto, you can open up the Q&A as well at the bottom.
Got it.
And why don't we,
Yeah.
Irvin
So
or Jackson, you want to give him a question, or do you want to find your own questions?
I'm happy to take, happy to have you guys sort of like, as observers, help out with this. It'd be great.
Sure.
Here's a good one from Deborah Roll. She says, some of my pots develop a pale yellow fungus on the surface of the soil or around the edges between the soil and the pot, or around the drainage hole. What is it? She says.
Yeah, so I actually recommend doing a Google search for yellow fungus, and it's a fungus. It doesn't hurt the plants. That fungus shows up because conditions in the soils, and it's a very common fungus. It's found, I may dare say, all over the world. And it shows up in containers, and it just shows it gets into the soil, and it's sort of breaking down some of the organic matter that's there. But as far as the plants, unless it gets really dense, it's not really a problem. It does modify the availability of water to get into the soil. So it can be a problem if it's growing really dense, but the best thing is to just sort of pop it off, and when it's right, repot your plants to minimize that. It shows up because of environmental situations, and so you might want to try to figure out what you can do to change change situation so it's not happy.
Ernesto, before you continue on here, do you want to stop your screen share? That we can see you a little bit better.
Yeah, we'll do that, and I'll just pop back up in case people have questions about any particular slide. Okay. Yeah,
Sure.
Thank you.
Hey, there's a question here about the use of lava, the lava mix, and why do you use it at all? If you found that it could harm the plants in the future, why do you use it at all?
That's a really good question. I think I guess the idea is that it has some nutrients, that some minerals that aren't in pumice, and so if you don't use too much of it, then it might have some beneficial influence on the plants. But in the past, we didn't use it at all, and our plants grew just fine. So something that needs to be researched more. Honestly, I can't say 100%. Yeah, it's good for plants, but a little bit is not bad like a lot of it is. So yeah, I think it needs to be researched more. That it's actually a really big horticultural topic that I think some really good quality research needs to be done to really figure out what's going on there, because there's a lot of evidence out there, but it's not measured evidence.
What about expanded shale? You didn't mention that at all, but we use that a lot here.
Oh, do you? And is it broken, or is it nicely rounded, the nicely rounded stuff?
Both.
Both? Yeah, expanded shale is functions like clay, And so I would suspect that the more jagged, broken stuff would be much better than the one that's nice round little balls. But that should be about the sort of quality of pumice. But I really don't. I haven't used it very much at all. So it'd be really another good one to compare, because that product is much more available these days. Yeah.
Ernesto, have you used Turfus?
We've used it sparingly, mostly for propagation. I have found, especially when it's not sterilized, not pasteurized, that I tend to have gotten some fungal activity when I try to use it for some of my seedlings. So I do want to play around with using some of the coarse turfase, the really coarse stuff, in combination with some pumice, because turfase has clay in it, and so it's going to grab more nutrients than does pumice. So a small amount of it is kind of like organic matter. Yeah, so it's a really good question, and something that, again, if I had time I'd play around more to use that versus organic matter. Yeah.
Somebody's looking for a pH meter that actually works.
Well, there's some pH strips that you can buy on Amazon, and look at the reviews. I'm not going to plug any particular one. We use one of these, the ones that sit in moisture, called I think it's like X-Tech pH meter. It also measures cation exchange, the amount of nutrients in the media, and electrochemical, call it electroconductivity, which is a measure of how much nutrients are in there, and does pH. So that's what we use, and then I have to replace it every couple of years because the sensors sort of fail after a while. So yeah, but you can buy really inexpensive ones that are probably going to work for you for at least a few months on Amazon. But I've heard some people have really good success with the pH strips.
There's a question here that asks, are mycorrhizae associated with succulents? And I'm going to expand on that to, do you see any benefit to adding a mycorrhizal additive to soil mixes?
All I can say is that in deserts, fungi are important in wet years. And in wet years, there's a lot more plants rotting and dying from overwatering. So I'd be very careful to tread on that one, especially if you don't have really good drainage. My suspicion is for desert plants, mycorrhizae probably do help, but in general, I'd be really careful promoting too much fungal activity for succulents, because it needs regular moisture, and regular consistent moisture is bad for a lot of, especially the more obligate cam plants and plants that are really water efficient. So I'd be really careful with that. But again, I that's all I would say, is I'd be careful with that. I can't say anything further about that.
Well, Ernesto, we have 71 people with questions for you, so we'll see what we can do here. So probably get through all of them. So Irving or Jackson?
Sure. Ernesto, are there any plants you'd recommend bottom watering for, or would you recommend top watering for all of them?
Ooh, if you have good clean water that's very low, got low amount of minerals in it, ions in it, that you've added a small amount of nutrients, then yeah, you can get away with bottom watering for a good while. But if your water has any amount of salts that are abundant amount of salts, I would be really careful with that. People talk about bottom watering when they're doing seedling pots, so they don't hydraulically mine the soil, and doing that for a little bit. But in general, unless you have really good clean water and you really know what you're doing, you should be watering from the top and letting it drain out and flush out salts, because yeah, you could really quickly start adding a lot of salts and minerals that the plants don't need, that have toxic effects very easily. So only bottom water if you really know what you're doing. That's what I'm going to say.
You know, Ernesto, in your presentation, you said you gave a recommendation spring or to midsummer for repotting your plants. Was that for all plants, even including winter growers, or just for the summer growers?
Good points. Good point. A lot of people don't grow a lot of winter growing plants. They typically grow more spring and summer growing plants. So that was for summer growing plants. Now, when I start doing my bulbous plants, my winter growers, I'm going to start doing them this next month, just as they're coming out of dormancy. We just did a bunch of winter growing plants. We're doing them at the conservatory right now, getting them ready because they're coming out of dormancy. So yeah, winter growers, this is now they're coming into their active period. So yeah, it's a good point. That's why I mentioned that when the plants are active or beginning to or actively growing. So it's really important to note, is it a winter grower or summer grower, or is it something that grows year round? Yeah.
You
Good
haven't
question.
mentioned perlite, which seems to be the most common non-organic source. What is your experience with that?
A lot of our succulents are kind of top heavy. And whenever I've grown a plant for too long in a mix with lots of perlite, my plants start falling over more. Perlite, like, it floats to the top of the mix, only near the surface, but it works. Okay, it works. But in a situation where I'm growing hundreds and thousands of plants, pumice, a heavier media, is much better to keep the pot stable than perlite. People talk about how perlite packs down. Well, it takes a lot of work to pack it down and really break it down. Perlite is actually also made in a blast furnace. It takes a lot of energy to make it because it's basically popcorn, water and a mineral that's popped and made into popcorn. It takes a lot of energy. So pumice is actually more sustainable than the man-made perlite, which is lighter and cheaper. And when you breathe in perlite dust, it's not good for your lungs. So it is really available. It works. Just in my experience as a horticulturalist, I only use it for propagation when I'm making cuttings in combination with vermiculite, but I don't use it as a long-term growing media because it's so light and unstable. And it's really important for roots to lock in and not move, because roots are not used to a lot of movement. Okay, so that's another benefit of using a heavier, more mix that locks in. Yeah.
Somebody asked about pH management for in-ground growth. Do you do any managing?
That's a really good question. I would say that when plants are in the ground, even though the soils can be alkaline typically, especially like here where I'm in Northern California, because the plants have a much more extensive root system, it's not as much of an issue. It probably will help to acidify, but it's not as nearly as important of an issue as it is in a container where you have a finite volume of soil and your roots really have to work really well, compared to when you have a plant in the ground and your roots can go out 4 or 5 feet away from the plant. The plant can make up for the less ideal environment by having the extensive root system. So it should help, but it's going to help a lot more in a container. Really good question. Thank you. Yeah. Someone asked, is acidification based on tap water? Definitely. The quality of your tap water is really affects how much you should adjust your pH, because is the tap water does it just have an alkalinizer in it, or does it have minerals plus an alkalinizer that takes a lot more work to get the pH to the right level? Yeah. Any other questions that you all see out there?
Someone asked about coffee and tea, and
I see that. Okay. And I learned this from a person that teaches an engineering class based around coffee production. And she pointed out that when you make your cup of coffee, the acid in coffee is really water soluble. So when you make your coffee and then you have your coffee grounds, they're really rich in organic matter, but they have very little to no acid left in them at all. It's the, you know, if you're going to give your plants some acidification with coffee, then you make your coffee and you give a little bit of that coffee in the water. Okay. So don't drink it all. That's very selfish. If you want to acidify your plants, give them some of the actual, you know, coffee that from the cup that you made. All right. Yeah.
I am going through and typing some answers to some of the questions just to get a few more answered here. So
Great. Thank you.
One person asked about using azomite. Are you familiar with that?
I'm not familiar with azomite at all. I'm not sure what that is.
I do use azomite in my cactus mix. It's a volcanic nutrient, micronutrient fertilizer.
Oh.
I think I want to say it's from Utah.
Yeah, I use it too.
Okay.
I also use it in my garden on peonies, so it seems to work.
Okay, so it's some kind of mineral that breaks down and releases some nutrients for the plants?
Yeah,
It's
just the
not-
micronutrients.
It's like a powder. It's ground very fine.
Oh yeah, okay, micronutrient powder. Yeah. Okay. And you know what I'll say with something like that, and nutrients in general, it's with nutrients, especially for succulents, less is more. If you overdo it, you can have some toxicity effects, where if you underdo it, the plants will grow a little bit slower and get those nutrients. But when you overdo it, you really can cause some problems. Okay.
Someone asked about mira acid and whether that could be useful.
Yeah, mira acid, I forget what kind of acid it is, but it's an acid and it has some nutrients in it. So it is going to help. But again, you want to be taking some measurements and making sure you adjust, you use it at the right amount, get the pH right, and not just take a guess and use it, because you can start causing problems.
One person in the chat room said he recommends phosphoric acid over vinegar because vinegar can add acetate to the soil and cause microbial growth.
Okay.
How easy is it to buy phosphoric acid? I mean, can you get it at any hardware store? That's something that's new to me.
Yeah, you know, I'm not familiar with how available it is, but my suspicion is Amazon has it available. Okay, and you know, phosphoric acid is on the side of the stronger acids. It's not a very strong acid, but you want to be careful in handling it. You wouldn't want to be doing it with your bare hands. You want to be wearing gloves, because it could cause damage compared to like citric acid and vinegar. Like you're saying, it has some problems with vinegar, but it's a much safer acid to use for the human side of component. Yeah.
I would assume it would be pretty easy to find because it's used as like a metal preparation for painting or refinishing metal. So
Okay.
Like rust removers that are pure phosphoric acid.
Got it.
Things
There
like
you go.
that.
Yeah. When I was doing some acidification in one of my greenhouses, and I like using the citric acid because I could take a 10-pound bag and put it in a 55-gallon drum, and then it just adjust my dosatron, and it was just citric acid, the weak acid. I mean, we drink it all the time, right? So it's a safe acid to use. But yeah, phosphoric acid, the benefit is you're going to get a little phosphorus added to your plants as well.
We don't, in the chat room, there's a comment by Petra Christ who says most hydroponic stores have phosphoric acid, and it's a little bit more natural. It's on the natural side. So,
okay.
Oh, there you go. Okay, yeah, that's right. Hydroponic stores have a lot of these things available. That's right. Yeah, and they're everywhere.
If there's a point of diminishing returns mixing different or inorganic materials in the potting mix.
There was a grad student at UC Davis a number of years ago that tried to measure what happens when you take different media and mix them together to make a container media. And it's this whole, like, there's a whole bunch of variables involved. And, you know, what I can say is, like, C&J, they use perlite and organic matter for their mix, and it works really great for propagating their small young succulents and getting them out there. Okay. It doesn't take a lot to get the right media. You just need to have a well-drained mix. So for oxygen, you have to have some amount of nutrient holding. That's where a little bit of organic matter or some clay, calcine clay in there. So, you know, water, nutrient holding, and then just the pH and, again, temperature. So it doesn't take many variables. And I've heard of all sorts of recipes that people have out there, like us. Do we really need the scoria in the mix? Good question. It's just a few simple things. I mean, you know, Petra, she grows most of her succulents in pure pumice. What does that mean? She has to water a little bit more often and add more nutrients than someone that has more organic matter in there. So you have to adjust accordingly. But it just takes about, well, like 4 or 5 variables that you need to have your plants happy. I mean, you could grow plants in pure gravel if you know, adjust things accordingly for the sake of that media.
I have one comment, because a lot of my growing is done with seedlings, and then I grow them in the loosest possible. I use pumice and sand mostly. I don't use organic material at all, because my growth, once I get the plants to 1 to 2 years old, they go out in the ground. And so I think if you're doing that, you have a different philosophy than if you're going to grow something in a container forever.
Yeah. Yeah. And, you know, again, you know, the question of the fungi and the plants, well, in the deserts, is there much organic matter?
There
No.
can be. It depends.
There can be. Yeah. In some years there are, right? But in general, the plants are adapted to very well-drained, coarse media. And there isn't a lot of organic matter, which means there isn't a lot of fungal activity. You know, it does help because it does hold nutrients, and it does, you know, create a little biology in the soil that can be beneficial to the plants. But, you know, too much of it can be more of a liability to the plants. Like I grow Welwitchias from seed, and I can grow them in pure pumice, and they grow much better, much faster. But when I grow them in a mix with some organic matter, they grow slower, but they don't die as easily on me, because those plants, they can dry out very easily because they're really not a succulent, they're a desert plant. And so by having a little bit more water holding more organic matter, they don't die as easily on me, but they don't grow as fast.
Our speaker 2 weeks ago was Roy Early on lithops. And he said, surprisingly, most lithops in the field have a lot of organic material in the soil from animal droppings and things like that. And so he said they really do better, in his experience, in the greenhouse with more organic material added to their mix. It's pretty,
you know, all I can say is that, you know, Steve, I've heard from Steve Hammer, someone visited Steve Hammer recently, and, you know, he hammered the point that he doesn't use any organic matter in his media, and his plants grow really well. So,
I guess
you know,
your way.
Well, yeah, and you know, again, it's because what are you doing? What are the variables that you're combining to make the plants happy? And you know, what I do whenever I get a plant from somewhere, what I should do, and I do most of the time, is I get it from their media and I transplant it to my media at the right time so that I can grow it under my conditions. Because whenever I leave a plant in the media of some other grower, I'm gonna have trouble because you know, my water regime is, etc. So it's really important to get things into your media so that you have your consistent techniques that you're using.
And a good point to add to that is that you should take all the soil off the roots by swishing it in a bucket of water. That's what we do a lot here in Denver.
Oh, do you? Okay. Yeah.
I'm with the roots just in the new medium so that there's no old medium attached to the roots.
Got it.
So here's a different question here. Roxy Esterly asks, are there any benefits to horticultural charcoal?
You know, I'm going to say that a small amount. Charcoal has a lot of it's organic matter that's sort of kind of, I don't know, stabilized by having been burned. probably will release a little bit of nutrients. It's organic matter. It's going to grab nutrients. So a little bit in the media shouldn't hurt. I haven't done any experiments where I grew succulents in pure charcoal to find out what happens to quantify it, but a little bit wouldn't hurt. Okay.
Ernesto, do you have any? Oh, go ahead.
Go ahead. Go ahead.
Do you have any experience with fish emulsion?
Fish emulsion. Hey, it's you know, lots of it's got lots of what is it, nitrogen in there. It's, you know, you can water your plants with it. They get a decent amount of nitrogen. It's gonna stink up your growing area for a while and bring in the flies. So hey, if you have some pseudolithos or some, you know, fly pollinated flowers, it's a great time to water with that stuff. But you know, I'm not gonna use it in my greenhouses and have them smell like, you know, fish for a day or two.
You know, Ernesto, we still have over 350 people, and instead of getting fewer questions, we seem to be getting more questions. So we'll try to answer as many as we can in a few minutes here. I want to thank everyone for. I know it's a topic that interests many people, and so we'll do our best to do everything, but I don't think we can spend all day long because they keep on coming in, and
Yeah.
just maybe have one day of just Q&As about what we're talking about. So let's go on. Anybody have any more things to? Some of the questions are getting longer and longer here.
I think
Well, you know,
you need to write a book on Ernesto. That's what.
Oh my gosh! Well, I need to do more research to be able to write that book. You know, whether my own research or sort of coalesced research that has been done out there. But you know, someone asked. They said previous versions of this lecture compared scoria to calcined clay, and Ernesto concluded that scoria is much better than calcined clay for root growth. Well, that was actually in propagation. When I was doing some propagation, I was comparing scoria to calcined clay, and I mentioned the fungus problems because we actually sterilize or pasteurize our media, including the lava, and the calcined clay. I had some problems with fungal activity in them with seedlings, and so that was my initial results, that I wasn't happy with the calcined clay, pure amounts of it. So I need to work on it more and probably pasteurize it and see how it works for seedlings. So that's my answer to that.
So let me make sure I understand. Most of your other growing medium for seedlings was pasteurized, but the clay was not?
Yeah, exactly. Yeah.
Okay.
You know, I kind of assumed that because of the way it's made, that it was fired and heated up, but somehow I had fungal activity in it. And so, yeah, I was happy more with the scoria. But yeah, yeah, all our media we pasture. Whenever I do seedlings, unless I know that they're going to grow really fast and they're plants that can handle, you know, they're not going to have fungal problems, fast growing plants, I won't pasteurize the mix or sterilize it. But our main media, our succulent mix that I talked about, we take those and pasteurize it by the yard, so that it's nice and sterile for the plants. And it's really important, you know, for seedlings. People talk about, oh, you know, isn't you know, fungi and, you know, their mycorrhizae really good for my plants? Well, you know, out in nature, most seedlings get, you know, they die from drought or something eating them, including fungi and bacteria. And when you're propagating plants, you don't want those things to eat your plants, and so you want to give them a head start by not having a lot of biological activity. I wouldn't grow Astecium or slow-growing cacti in an organic rich media that's not pasteurized, because the math is not going to be on the side, the probability is not going to be on the side of your seedlings surviving, if that makes sense.
So Dan Noonan asks, are any of these charts that you displayed online somewhere? Do you have a web page or somewhere people can access that information?
Yeah, so most of the charts that I have, I'll share my screen again here, are available via this this link here that I have, and I'll add this talk to that my set of talks that I have available on this website right there, greenhouse.ucdavis.edu greenhouse.ucdavis.edu/conservatory/resources. If people just go to the website greenhouse.ucdavis.edu, they can get to the link of my lectures, and I'll add this one on there. But most of those charts are already on there. I think I'm not sure that I've added this talk with the pH stuff in there, so I'll add that in there this afternoon.
But Jackson, could you do me a favor and copy that URL on to the chat page?
Yep.
Oh yeah,
Okay.
what I can do like, let's see if I can get it so that I can copy. Oops, sorry, excuse me. Did I stop the share?
Yep.
There we go. Okay, and I can paste it in there right now because I can copy and paste it from there right now. We want it in the Q&A?
You put it in the chat room.
In the chat? Okay, great.
Put in chat, because chat will be, we don't keep copies of the Q&A, but we keep copies of the chat room stuff.
Ah, there we go. Okay, I got the link in there for you guys.
Cool.
Great.
All right.
Yeah.
So,
So I know that there's a limited time for this, but I'm willing to stick around till 11:30 if that's okay.
well, we don't want to overstay our welcome here.
There you go.
Why don't you, if you stop sharing your screen again,
Oh,
we
yes.
move on. And we
There we
have a
go.
couple, maybe 3 or 4 more questions, and we'll call it a day.
One
Petra-
question.
Oh, go ahead.
One question here that summarizes, I think, a couple is, do you have any recommendations on what the best kind of organic material to add to a soil mix is? Whether that be regular potting soil, compost, etc.
Yeah, what I can say is that a lot of growers are now switching to the coconut peat, which is a more sustainable source of organic matter than peat moss, which is unsustainably harvested.
Ernesto,
So go ahead.
the coconut peat is the same thing as cocoa coir?
Core.
Yeah.
And speaking of core, you can get that at hydroponic stores as well.
There
I'm
you
sorry.
go. Yeah, and most people don't need the quantities that I need, right?
Right.
But
You can get them in bricks. If you get the big quantities, it's kind of fibrous and it's hard to break down. And I know someone put them in cement mixer just to get some of that fiber down. But I think if you get the bricks at a hydroponic store, and they soak up pretty well in a 5-gallon pot and 5-gallon container.
yeah, and back when more redwoods were being harvested in California, for better or worse, redwood compost is great because it doesn't break down. That organic matter doesn't break down very fast. You want to be careful not to use compost out of your garden, because that's going to continue breaking down and becoming very fine. And that's where something like the coconut coir or peat, is much better. And again, that's pretty readily available these days. So you can, a potting mix that you buy at the store, and if you cut that with the inorganic material, whether it be lava or scoria or pumice, is going to work pretty well.
Ernesto, have you, Petra Christ asked about adding humic acid. Have you any experience with that?
No, but that's it's organic acid. I'm not sure how it's pulled out of plants, but yeah, I mean, I suppose it's anyways, I don't know much about it, honestly. Yeah, I have to do some research on it. People that want to go more organic and use more sort of natural materials, I guess you'd have to do more research on that to figure out what exactly is going on there, as I do. I'm sorry.
Somebody was asking about companion plants other than poppies to indicate moisture. What about like oxalis?
Well, you guys might remember Sam Williams. He had a little grass that he had in his greenhouses, that a little weedy grass, and it didn't get very large, so he liked to use that as his moisture indicator. I would be very careful of using Oxalis canaliculata, that little weed, the greenhouse weed that we all have, because you quickly have way too much of it. So, I actually use in my greenhouse, I use a Pareschiopsis and a Parescia actually as my moisture indicator, but I also use a few other really tough plants that wilt but don't die very quickly. And I can't think of what some of those others are, but I use them throughout my greenhouse as my moisture indicators. So find the ones that are tough, that don't die easily, that wilt, and then will rehydrate.
One of our members from San Gabe uses Pelargonium.
Oh, there you go. Yeah. There you go.
So before we leave off today, Ernesto, your web, this, by the way, for everyone, this presentation will be online until the end of the weekend. Ernesto, do you mind if we put the Q&A online separately? Because people may want to go back to refer to just the Q&A section.
Definitely, no problem at all. Happy to share.
All right, cool. All right, so any more questions? Looks like we started off with 69 questions. Now we have 63 questions. And we still have, so this can go on. And I think that we will take for that, and we've got 3 more minutes. So maybe one more question in 3 minutes. That ought to do it. How about that?
There are 2 things that I see coming up quite frequently. One is using lemon juice instead of vinegar for soil acidification. And then the other one is about insulating the pots with terracotta, possibly by putting a plastic pot inside a terracotta pot, and whether or not terracotta is a high fire ceramic.
Yeah, terracotta, I believe it's sort of a medium fire ceramic, and it's actually great for insulation because, again, it traps air. And I did that in my outdoor growing areas. Wherever I had sun kind of coming in, I would take my plastic pots and drop them inside of clay pots for insulation. On some of my benches, what I do outside is I'll have wood, that goes up as tall as the pot is to keep the sun from beating directly on the containers. Yeah, and then the first question, just remind me what that was, the comment, first part?
What about using lemon juice?
Lemon juice. Oh yeah, lemon juice is citric acid. I'm sure it'll work. It's going to be very low amounts. It's going to take very little to acidify, so it should work. I don't know of any detrimental effects. I had really great success with it when I was using citric acid, not lemon juice in particular, but citric acid. I would be worried with the lemon juice if it has a lot of sugar in it, that you're gonna start doing some funky stuff in the soil with the sugar.
So maybe one more question along the lines of citric acid. What is the dilution of citric acid crystals in water?
Very high. It's citric acid is very water soluble in water. So you can take 10 pounds and I think even in like 10 gallons of water, you'll take those 10 pounds and they'll solubilize in there. Okay. All right. Any last thoughts or no? Okay. Ernesto, once again, thank you so much for your wonderful presentation. We could go on. Yes, we could go on with days with this thing here. There's still 275 people, and people are saying thank you for the wonderful presentation, and we all agree on that here. But I think with 63 unanswered questions, we'll have to let it go and keep it for next time here. Maybe you can come back sometime and we'll do a part B for this thing. Okay. Pleasure.
All right.
Yeah.
All right. Thank you, folks. Have a wonderful weekend, and we will see you in 2 weeks. Irving, thank you. James, thank you. Rod, thank you. And Jackson, thank you very much. And we'll see you again in 2 weeks. Okay.
Bye now.
All right,
Bye,
folks.
guys.
Bye.